So let's take this interesting example. What is the requirement of this particular question? As we said in the section that you're going to form signs. As in, if a particular shaded region has been given and the equations of the lines have been given, from that, how do we form the signs for the inequation which could represent that particular region with respect to the regions formed by these particular lines? So, hence, with the help of this, so for example, you have these 4 lines L1, L2, L3 and L4, the region that we have over here. What is that region in terms of signs of inequation with respect to these particular lines? Hence, the requirement of the question is to arrive at the signs of the inequations which will justify this particular region or which could describe this particular region in terms of inequations that are represented at this particular line. Now, let us see how to go about doing this particular examples. Let us actually calculate and see how to do it. Okay, let us take this particular illustration. So we have this region which has a boundary of 4 lines. You have L1, you have L2, you have L3, L4. As you see, L1 is passing through 6, 0 and it is also passing through 0, 10, which if you see, it will be satisfying this particular condition. And x plus y is equal to 9 is this particular line. Now let us see this particular region, that is this particular region with respect to this particular line. If you see, this region is moving away, it's moving away from the origin. So this particular region that is there will be falling in the region 5x plus 3y is greater than or equal to 30. So this is how this region, this is just one part of the whole thing. Let's consider the line L2, you have x plus y is equal to 9. This region is to the origin side of that particular line. That means it is going closer to the origin. So it has to be in the less than region. So it's going to be x plus y is less than or equal to 9. Now, let's consider y is equal to x by 3. That is line L3. So we can take this particular point. If you take 6, 0, if you put over there, you have 6, 0. Substitute over there, you get 0 on this side and you have 6 by 3. You have 0 and you have 2. 0 is definitely less than 2. So that means you have a case wherein y is less than x by 3. So this region below is y is less than x by 3. So this region is above that. So it's going to be y is greater than or equal to x by 3. So this region is above. So we have this, we have this, we have this. Coming to the last one, this particular line L4 again is going to be, if you look at this point, maybe even 6, 2, 6, 2, if you look at it, you have x is 6 and y is 2. Substitute these values, you get 2 and you have 6 by 2 and you have 2 and you have 3. 2 is less than 3. So this particular region below for L4 contains y less than x by 2. So it is basically a combination of 5x plus 3y greater than or equal to 30 because this region is on the non-origin side of the line L1. X plus y less than 9 and hence because this region is on the origin side of this particular line and this region is also enclosed by y is greater than or equal to x by 3 because when we substitute the values over here, it is on this side. So these are all the regions where y is less than y is greater than x by 3 and you have y is less than x by 2, that is line L4 and hence this part of it below it, hence you have y is less than or equal to x by 2. Hence this region is a combination of x plus y less than or equal to 9, 5x plus 3y greater than or equal to 30, y is greater than or equal to x by 3 and y is less than or equal to x by 2. Hence, this region is bound by that. So see, here we have the answers. We did the region. We have 5x plus 3y greater than or equal to 30, x plus y less than or equal to 9 because it is in the origin side, this region, and this is in the non-origin side. And of course, we have L3 represented and the region is above it. So we have y is greater than or equal to x by 3 and y is less than or equal to x by 2. And most importantly is that what I mentioned in the previous example, since this particular region is falling in the area where both the x coordinate and y coordinate are positive, it is essential to mention that x is greater than 0 and y is greater than 0. Hence, this is how we have arrived at the situation like this. Fine, let's go ahead with the next example here. So this particular example is arriving at the relationship between the various regions and the signs. Let's see the next example. So here you have a particular region here which is enclosed here, which is a combination. You can see there is a grid formed over there. So it includes, the grid neatly indicates which is this region is, how did we arrive at this particular region? So let us see how it is. So you have this particular line over here, 2x plus y is less than or equal to 8. And if you see, this region is on the origin side. So yes, 2x plus y is less than or equal to 8. And you have the line y is equal to 5. And again, this region falls in y less than or equal to 5. So we have y is less than or equal to 5. And you have this particular line x is equal to 2. This particular shaded region is falling on the origin side of that particular line. So this again is x is less than or equal to 2. And the most important thing that is there we have here is that again this region is in the what is called as the first quadrant, where the values have to be either positive or 0. So it has to include x is greater than 0, greater than or equal to 0, and y is greater than or equal to 0. So that means if you look at the signs that are formed, it is a combination. This particular region is represented by the overlapping regions of 2x plus y is less than or equal to 8 because it is in the origin side of this particular line, and y is less than or equal to 5 because it is to the left of y is equal to 5, or it is on the origin side, and much the same way with this. And of course we need to indicate x is greater than 0, y is greater than 0. So let us see what equations, what is the combination you have over here. So here among these, definitely this is not valid. This is not valid because this is not indicating anything about x greater than or equal to 0. So this is not valid. This is definitely not valid. So this seems to satisfy all these conditions. So this is the answer. That is, this is the region including a combination of all. This is the region which is formed by the overlapping of all these particular regions. So this is the answer. So let's check what the answer is. Yes, we have 2x plus y is less than or equal to 8. X is less than or equal to 2. X is greater than, y is less than or equal to 5. I'm sorry. X is greater than or equal to 0 and y is greater than or equal to 0. So this is yet another simpler way of doing such examples. So to reinforce what we learned, let's go to the next example over here. So we have a case, again we have a triangle, and you see the triangular region that is there. If you have a region over here, this region has to be, we have to arrive at what this region is. So obviously it is enclosed by the line 2x1 plus x2 is equal to 6, x1 plus x2 is equal to 6, and the x-axis and the y-axis. So if you look at the line 2x1 plus x2 is equal to 6, and with respect to that particular line, you see that this region, this particular region that is there, is moving away from the origin. So it will be 2x1 plus x2 is greater than or equal to 6. So this is one part of it. So we have arrived at as to where this region lies, in which part of the line 2x1 plus x2 it lies. Now let's consider the line x1 plus x2 is equal to 6. If you look at the region, this region again, this region is lying on the origin side of x1 plus x2 is equal to 6. That means it's moving towards the origin. Hence we have x1 plus x2 is less than or equal to 6. Additionally, this region lies in the first quadrant, so it is x1, x2 greater than 0 as well as x1 greater than 0. Hence we have a combination of 2x1 plus x2 greater than or equal to 6, x1 plus x2 less than or equal to 6, x1 greater than 0 and x1 greater than or equal to 0, while x2 also greater than or equal to 0. So hence if you look at the options over here, it is the first option that seems to be satisfying all these four conditions simultaneously. Hence we say this particular set of conditions aptly describes this particular region on the basis of signs of inequations that are described by these particular lines. More ahead, let us see the next example. Let's check whether this answer is right, of course, first. Yes, this seems to be the right answer. This is the right answer. So let's move ahead with the next example. So here we have again a particular region over here. So let us take this particular line. You have 3x minus y and you have 0. And this line again is passing through the origin, so it's not so easy to decide. So let us consider x is 5 and y is 0. If you look at it, this means that y and 3x you have. This is meaning y and 3x. So if you take 3x, 3 into 5, and you have y is 0. So we have 0 is less than 15. So this particular region, that is y is less than 3x. So if you see this particular region involves y is less than 3x, which is meaning that 3x minus y is greater than 0, which means 3x is greater than y. So this region contains 3x minus y greater than 0. Now let's look at this particular line. This particular line is x plus y is equal to 5, and the region over there is on the non-origin side of it. So obviously this has to be x plus y is greater than or equal to 5. You have x plus y greater than or equal to 5, and 3x minus y is also greater than or equal to 0. So we have a combination of this region. Now look at what is the relationship between x and the in terms of signs. Now if you look at this particular region, in this particular region, x has to be greater than 0. We have to mention y can be negative. Y can be negative because this region is going below this 2. So it is going to be, you have to be clearly mentioned that x is greater than 0. So it's a combination of 3x minus y greater than or equal to 0, x plus y greater than or equal to 5, and x is greater than 0. So let's look at these examples. Among these, this one seems to be the right answer. So you have x plus y greater than or equal to 5, which is very clear because it is on the non-origin side. 3x minus y greater than or equal to 0. We substituted the values and found out. And in this particular region, we don't say y is greater than or equal to 0 because y can be negative and x is going to be positive. So among these, this one seems to be the right answer. Let us check what the answer is. Yes, we are right over here. So we move on to the next example. We have a particular case, that is a particular example wherein we need to decide which is the right region that is bound by this. In this, one thing is for sure, x is definitely greater than or equal to 0, y is definitely greater than or equal to 0. These two things are definite in this particular case. So now let's consider there are three lines involved over here which are inclined to the x-axis and y-axis. Let us consider this particular line 3x plus 2y is less than or equal to 24. Now this particular region that is there is closer to the origin. It's moving towards the origin. So it's going to be 3x plus 2y is less than or equal to 24. Already we got three conditions. Now let's take up this particular line. You have x plus y is equal to 16. Again, this particular region is on the origin side of this particular line. So we have, it will be x plus y is going to be less than or equal to 16. Coming to the last line, that is x plus y is equal to 10. If you look at this region, again that particular region is on the origin side, so it's going to be x plus y is less than or equal to 10. So we have this region which is determined by the overlapping of the regions determined by these 5 conditions. So let us see what are the conditions that are involved over here. So we have 3x plus 2y is less than 24 in all these options, and x plus y is less than or equal to 16, and x plus y is less than, so it is going to be option number C, as we see from all these. Let us check once again, and hence we have this particular region. Now remember, again I repeat it, whenever you have this kind of regions which are bound by the x and y axis, it is absolutely mandatory to indicate x is greater than or equal to 0 and y is greater than or equal to 0. Let's pause. Let's move over to the next particular example and check what we have over here. This is a much simpler example. You have a region bound by 2 particular lines. Here we have this particular line. This is 3x plus 5y is 15. This is of course 5x plus 2y is 10, and of course it is bound by the y-axis and x-axis, so definitely we need to indicate x is greater than or equal to 0 and y is greater than or equal to 0. Absolutely. So this is determined right from the beginning, so we already got 2 conditions. Now again, coming back to this line, 5x plus 2y equal to 10, this region is on the origin side of this line, or it is moving towards the origin. So yes, you're right. It's going to be 5x plus 2y is less than or equal to 10. Coming to this line, 3x plus 5y is 15. Again, this region is in the origin side. So we have 3x plus 5y is less than or equal to 15. So we have a combination of these 5. So let's see among these, which among these will be valid. So we have 3x plus 5y is less than or equal to 15, 5x plus 2y is less than or equal to 10, x and y both of them are equal to 0. So this is the right answer. And we will see, we are going to confirm that. So yes, that is the right answer. And we have another very simple example. We can just go through this very fast. Now this is concerned with the triangle formed by 3 lines. One of them happens to be x is equal to 2. So this region is going to be x is greater than 2. Anything to the right, that is, this region is away from the origin. So it's going to be x is greater than or equal to 2. With respect to y is equal to 1, this region again is moving up, away from the origin, so it's going to be y is greater than or equal to 1. Considering this particular line, this region on the contrary is moving towards the origin, so it's going to be x plus y is greater than or equal, is lesser than, is less than or equal to 5. Now we note that in this particular case, there is no need to indicate x is greater than or equal to 0, y is greater than or equal to 0, because in any case, it is going to be greater than or equal to 0, because this whole region is falling in the first quadrant. So x and y in any case are going to be positive. So it's a combination of this, this and this. So it's going to be x plus y less than or equal to 5, x greater than or equal to 2, but not y is less than or equal to 1. So it's going to be this particular option, that is x plus y is less than or equal to 5, x is greater than or equal to 2, y is greater than or equal to 0, 1. And once again, I repeat, we have to mention xy is greater than or equal to 0. So among these options, this is the right option, as we'll see in the solutions. Let's go through the next example quite fast. Now here again, we have regions like these involved here. Here we are not exactly mentioning, it also includes, we are not mentioning that this is not included by the x and y axis. So we have this particular line 2x minus y, or let's take this x plus y is equal to 6. X plus y is equal to 6 is the equation, and this region is on the non-origin side, so it's going to be x plus y is greater than or equal to 6, definitely. Consider things 2x minus y is equal to 0. This means that y is equal to 2x. So you consider any particular value 6, 0, so you get 2 into 6, and this is 0. 0 is definitely less than 12, so y is less than 2x. So this particular region, entire region, is y is less than 2x, which means that 2x minus y is greater than 0. So we have a combination of x plus y greater than or equal to 0 and 2x minus y, x plus y. So we have a combination of 2x minus y greater than or equal to 0 and x plus y is greater than or equal to 6. So the only possibility over here seems to be A. So we have this as the right option. X plus y is greater than or equal to 6. 2x minus y is greater than or equal to 0, which we confirm from the answers. So these are basic things about how we can judge from a graph as to what kind of signs can be included to decide a particular region with respect to the given equations of the lines. Now let's take this particular case. We need to find the solution space of this pair of inequalities. You have 2x plus y less than or equal to 10 and x minus y less than or equal to 5. Does it include the origin? Does it include the point 4, 3? We have to see various options among these. So the best way there is substitute the values and whether it satisfies or no. So let's substitute the coordinates of the origin. So we have 2 into 0 plus 0, and which is nothing but 0. Yes, 0 is less than or equal to 10. Similarly, 0 minus 0 is 0. 0 is less than or equal to 5. So yes, origin satisfies the inequation. Let's take this particular example 4, 3, the other point. 2 into 4 plus 3, that is 8 plus 3, 11, is definitely not less than or equal to 10. So definitely 4, 3 is not part of this. So among these various options you say, does it include 2? Definitely not. No. Both 1 and 2? No. Yes, only 1. So it's only the coordinates, the origin, coordinates of the origin satisfy this particular equation if you look at it. And we can confirm this, of course. Yes, we are right. It's only the coordinates of the origin that satisfy this particular relationship. Now that was a very simple one. We can move ahead. These are the kind of questions which you can attack in a very short time. Now let's take this particular interesting examples when the equation has not been given. That's a little bit of info I would like to give. Now wherever the line intersects the x-axis is called the x-intercept, and wherever the line intersects the y-axis is called the y-intercept. So in this case x2 is equivalent to y. So in such a case, the equation of such a line will always be given by x upon x-intercept. We call it as A plus y upon y-intercept. We call it as B is equal to 1. So in this particular case, this particular line is going to be x1, which is the same as x coordinate, upon the x-intercept, that is 4, plus y, which is the same as x2, upon the y-intercept, that is 4, is equal to 1. So the equation of this particular line is x1 plus x2 equal to 4. The equation of this line is x1 plus x2 is equal to 4. Now look at this particular line. This has x-intercept, that is on the x-axis, the x-intercept is 2. So we can write x1 upon 2 plus y-intercept is also 2. So it is y by 2, which is the same as x2 in this particular case, upon 2 is 1. So this particular line is x1 plus x2 equal to 2. So this line is governed by x1 plus x2 is equal to 2, and this is determined by the equation x1 plus x2 is equal to 4. Now this, if you see, this region is on the non-origin side, so it's going to be x1 plus x2 is greater than or equal to 4, and this is on the origin side, so here we have x1 plus x2 is less than or equal to 2. And again we come back to that familiar case wherein the line is touching, the region is touching the x and y axis, hence we need to indicate x1 and x2 greater than or equal to 0. So we have a combination of 1, 1, 2, 3, 4. But here if you see, we don't have anything called x1 plus x2 greater than 4. But we know that we multiply both sides of an inequation by the same number, the inequation does not change. So we have 2x1, 2x1 and 8. So obviously all these have been multiplied by 2. So you have 2x1 plus 2x2. You're multiplying by a positive number, inequality does not change. Now why do we do this? Because this particular option is not available over here. But we know that if you multiply all the terms of this inequation by 2, we can get one of these options. Hence, we are looking at this, this and this. So we have 2x1 plus x2 is greater than or equal to 0. x1 plus x2 is less than or equal to 0, and x1, x2 both are equal to 0, and this is being satisfied just by this. A little complicated, but we can get it done pretty simple. A simple concept: divide the x by the x-intercept, y by the y-intercept equal to 1, much the same way with the other line too. And the other things, of course, are concerned with finding the sign, that is greater than region or less than region. So we have this particular combination. Let's once again do the exercise of confirming, and yes, we have this particular combination working here. So we have done a few examples, quite a lot of them, to understand how to form signs with regards to a particular region. Let's take a few more examples. This is a very simple one. So here the inequalities x1 greater than or equal to 0, x2 is greater than 0 are represented by y. Obviously it's going to be this particular region. Which among these is this? So this is the right answer, because x1 is greater than or equal to 0, x2 is greater than or equal to 0. I don't think we need to check the answer for this, but nevertheless we got the answer right over there. Okay, let's look at this particular example. We have a combination of 5 lines, and with the arrow marks we indicate the signs. So looking at L1 and L2, they are the y and x axis, and the region bound is on the greater side. So it's going to be x1 is greater than or equal to 0 and x2 is greater than or equal to 0. Coming to line L3, that is this, and we are looking at this particular region, which is away from the origin. So it's going to be x1 plus x2 is greater than or equal to 1. Coming to L4, L4 is here, L4 is again here. We are talking about this particular region. Now this particular region again is away from the origin, so it's going to be greater than or equal to 0. Now look at this particular line, minus x1 plus 2x2, and you have 0. Now minus x1 and 2x2, what is the relationship with 0? Now let's take any particular point on the side mentioned for L5. So maybe this side, we can take any L5 is here and we're talking about this particular side, so we can take 1, 0 over here, maybe, which is not lying on L5, 1, that is x1 is 1 and y1 is 0. So if you substitute over here, you have -1 plus 2 into 0. So that means -1 is less than 0. So this particular region which is mentioned is obviously in this particular region we have -x1 plus 2x2 is less than 0. Since it is also bound by this line, it has to be -x1 plus 2x2 is less than or equal to 0. So here we have a combination. Remember, once again, with respect to this line and this line, we can decide from the origin side of the line as to how to form the signs. But when it comes to this particular line, it's passing through the origin. So we have a wee bit of a difference. So we look at some point which is lying in this particular region which has been mentioned. So that's why we took the point 1, 0 and substituted x1 as 1 and x2 as 0. And we found that -x1 plus 2x2 was actually less than 0. So this region is this. So we have a combination of these 5 cases. Let us confirm this. Yes, and we have these cases, as in we have x1 is greater than or equal to 0, x2 is greater than or equal to 0, and these are the combinations. Now we have just a few more examples wherein we have these cases. We need to decide among these 3 of these graphs, which among these 3 represents this particular combination. Obviously, all of them are true for x1 greater than 0, y1 is greater than 0. Now let us see x plus y is less than or equal to 5. So x plus y is less than or equal to 5 is L1. So this less than or equal to 5, all of them that is there, this one is, let us examine this particular case. L1 and x1 plus x plus y is less than or equal to 5. Yes, so this is the line x plus y is 5. This region is on the origin side. So this does have x plus y is less than or equal to 5, x is less than or equal to 0, x is greater than or equal to 0, y is greater than or equal to 0. Coming to x plus 2y less than or equal to 8. X plus 2y less than or equal to 8 is line L2. This is the line L2. Again, this region is on the origin side. So we have x plus 2y is less than or equal to 8. And the last line is 4x plus 3y is greater than or equal to 12. That means this particular region that is being mentioned has to be on the non-origin of that particular line L3. And here we have L3 and this is lying on the non-origin side. So this particular line 4x plus 3y is greater than 12 and this region. So this combination of these 5 conditions is being satisfied by this particular graph. And definitely not this graph, because this is not being represented by 4x plus 3y. This condition is not satisfied. Again, here one of the other conditions is not being satisfied. So it's only this region which is satisfying 1, 2, 3, 4 and 5 condition. There is only one region which is on the greater than side, and these 2 regions, the remaining 2 regions are on the lesser than side. Hence this is the particular option for this. Let's check the answer. Yes, that is the right answer.